Today, lesson 14a, day number 2 of subtracting integers. Yesterday, we talked about how to subtract integers with number lines. We also talked about one issue that we run into if we try and use tiles. Though we can use tiles, it can be a little bit tedious, and in many cases, it may be easier to just use a number line. So today, we'll be able to add the additive inverse, or the opposite, to find the difference of integers. And we will verbally describe how to compare integers to find the difference of the integers. And as usual, we have a why am I learning this? All right, let's get started here. A little bit of background knowledge. -3 plus -9. We, of course, talked about that with tiles. We also talked about with the number line. So if we were using a number line from 0, we would go to the left 3 units. And then we're adding a -9, so we would need to continue in that direction 9 more units, which leaves us at -12. -3 minus 9. We start at 0 and go left 3 units. And we are going in the negative direction, or continuing in the negative direction, 9 more units, and we can clearly see that we end up at the same spot, which should lead us to some sort of conclusion about the relationship between those two problems. And I know some of you were taught how to turn a problem like the second one into the first one last year. And so we would say that -3 plus -9 and -3 minus 9 are equivalent expressions. Equivalent expressions because they give us something that results in the same thing. So they end up becoming -12, and the reason is because of the relationship between what we see right there. So here's what I want you to do. 1 through 14. I want you to find the sum or difference, and then we'll talk about what you noticed there. Go ahead and find the answer or sum or difference between all 14 of them. Do all 14 of them. I mentioned equivalent expressions. We haven't really talked about what that term means yet. We will be coming back to that in another lesson very, very soon. But we see a lot of that in these 14 problems right here. Okay, quick conversation with your shoulder partner. What do you notice about what you see in these 14 problems? Go. And obviously, 1 and 2 have the same answer. 3 and 4 have the same answer. 5 and 6 have the same answer, or they should have. And the reason is because of the relationship between number 1 and number 2, or the relationship between number 3 and number 4, and so on. And it all comes from what you see right below that in your notes. And that's what we sometimes call the rule of subtraction. And the rule of subtraction states that subtracting a number is the same as adding its additive inverse. Or sometimes we say that as adding the opposite. And you're going to hear me say those words frequently. Add the opposite. Add the opposite. And what add the opposite or adding its additive inverse means is this. Turn a subtraction problem into an addition problem to help you find the difference. Okay? And so what we're going to do is we're going to do a little bit of practice of that. I know many of you know how to do that because you learned it last year, but I'd like you to write down these examples, please. What the rule of subtraction means is that A minus B is equivalent to A plus -B. So here I bring up those 2 words, or 1 word, equivalent. I guess I did say both of them, equivalent expressions. Those 2 words again, which we will come back to in further detail. Here's another one. 7 minus 10 turns into 7 plus -10. 7 minus 10 and 7 plus -10 are equivalent expressions. They are expressions that look the same and give us the same solution. I'm going to keep going here. -11 minus 9 is equal to -11 plus -9. I have added its additive inverse or added the opposite. Those are equivalent expressions. Here are a few more. A minus -B is equivalent to A plus B. -8 minus -5 is equivalent to -8 plus 5. 15 minus -6 is equivalent to 15 plus 6 by adding the opposite. So at this point, we're going to do a little bit of practice of writing equivalent addition expressions for each subtraction expression. In other words, we're going to add the opposite. Go ahead and do all of the ones that are in the table. In other words, I would like you to go ahead and write equivalent addition expressions for 15 through 22. Go ahead. Negative 7 minus 3. The equivalent addition expression is negative 7 plus negative 3. If you did not get that, fix it. 6 minus 11. The equivalent addition expression is 6 plus negative 11. And I'll continue on here. 12 minus negative 3 is equivalent to 12 plus 3. Negative 6 minus negative 8 is equivalent to negative 6 plus 8. 19 is 14 minus 10 is equivalent to 14 plus negative 10. Now, just to make it clear, I would never add the opposite in number 19, right? It's like a first grade problem. Number 20, negative 2 minus 7 is equivalent to negative 2 plus negative 7. 21, negative 8 minus negative 10 is equivalent to negative 8 plus 10. And 22, 5 minus negative 9 is equivalent to 5 plus 9. One of the reasons why we do this is most people would agree these problems, these addition expressions, look easier to deal with than the subtraction expressions. They're equivalent. They'll give us the same answer, but most of us probably feel like these are a little easier to deal with. Some of you in here, you don't need to do it because you just get what to do, but we're going to still do a little more practice of changing them before we find the actual simplification of the expression. And by the way, it did say here to simplify the expression. This one, of course, is negative 10. This is negative 5. That's 15. That's 2 because we have 2 more positives than negatives. This is 4 because we have 4 more positives than negatives. This is negative 9 because we have 9 negatives and 0 positives. This is 2 because we have 2 more positives than negatives, and it is clear that the last one is 14. Okay, so let's go to the back side of your notes. And you're going to rewrite each of the following as an addition problem, much like you did in 15 through 22. And then now there's a column for you to write the simplified version of it. In other words, write the answer for each one. So go ahead and do 23 through 32. And when we are finished, we will compare everything with our shoulder partner. Number 23, the equivalent addition expression is negative 2 plus negative 6. The simplified version of that is negative 8 because we have 8 negative symbols and 0 positive symbols. Therefore, we have 8 more negatives than positives. Number 24, the equivalent expression is 9 plus negative 14 after I, of course, add the opposite. And that's what I will call it from now on, adding the opposite. We have 14 negatives and 9 positives. We have 5 more negatives than positives. Therefore, the sum is negative 5. Number 25, when we add the opposite, that becomes 7 plus 4. We have 11 positives and 0 negatives. Therefore, we have 11 more positives, so the sum is 11. 26, after we add the opposite, it becomes negative 10 plus 7. We have 10 negatives and 7 positives. It should be clear to you that we have 3 more negatives than positives. And one of the things that you could be doing to help you out here, for those few of you who are struggling with this idea, here's what adding the opposite means. Add the opposite. Add the opposite. Add the opposite. Add the opposite. That turns into negative 8 plus negative 12. Add the opposite. That becomes negative 5 plus 3. Add the opposite. That becomes 6 plus 8. Add the opposite. Change the addition symbol or subtraction symbol to addition. Change the second number to the opposite of what it is. That's one way of thinking about it. Add the opposite. Add the opposite. That's what's happening when you're adding the additive inverse or adding the opposite. So, going back and doing these again, 27 turns into negative 8 plus negative 12 after we add the opposite. We have 20 negatives and 0 positives. Therefore, 20 more negatives than positives. 28 turns into negative 5 plus 3. We have 5 negatives and 3 positives. We have 2 more negatives than positives. 29 turns into 6 plus 8. We have 14 positives and 0 negatives. Therefore, we have 14 more positives than negatives. 30 turns into 4 plus negative 21. We have 21 negatives and only 4 positives. We have 17 more negatives than positives. 31 turns into negative 20 plus negative 16. We have 36 negatives and 0 positives. Therefore, we have 36 more negatives than positives. And number 32, after we add the opposite, the equivalent expression is negative 22 plus 24. We have 22 negatives but 24 positives. Therefore, we have 2 more negatives than positives. Any questions about anything in this chart? Okay, so let's take a look at number 33. Number 33 says, and I'm not switching over up here because I know a couple of you are writing things down. Number 33 states that using the integers 6 and 2, create an addition expression or a subtraction expression that will simplify to negative 4. Go ahead and try number 33. Once again, I forgot this was coming, but can all of you turn to your shoulder partner? What do we know so far? Go. Heard lots of good conversation there. Getting back to number 33, we were supposed to use the number 6 and 2 to create an addition expression or a subtraction expression that will simplify to negative 4. Now, I'm going to ask for lots of examples. Some of you may have got a sum or a difference of negative 4, but you didn't follow what it was telling you to do. And I'm hoping I will get some of those. So somebody give me one expression that will simplify to negative 4. Caleb?
Negative 6.
What they have. Yes.
Negative 8 minus negative 11.
All right, so you use negative 8 and negative 11, and that does have a difference of positive 3. Anybody have something else? Yes.
I got the negative outside parentheses and negative 11 in parentheses plus negative 8 in parentheses.
Is this what you said?
Yes.
Okay, would that have a sum of positive 3? No.
Negative, so.
Yeah. So this part right here actually ends up being 11.
So yeah.
So is it? Does that work? Yeah. Sure, it works. Okay, so that would be 11 plus negative 8, and that also is positive 3. All right, we are finished for today.